Hey guys, I have been asked to do a couple problems from, this is the, make sure you know what I'm doing here. This is from the combining like terms, okay, the combining like terms, additional problems, right? And what's nice about this, again, that there's examples on the front page that I recommend looking at. So you can watch, especially when you look at one that's a little bit more complicated, see how they take that number, excuse me, that expression, and rewrite it to put the like terms next to each other. So that way you can see, oh, okay, so the 4x squared, the 2x squared, those are like terms. So basically rearrange it so that way all the like terms are near each other, then simplify it, combine to come up with the answer, okay? So I'm going to look at numbers 9 and 10. So number 9, we'll start with that one. Number 9, we're looking at our like terms. We're looking for like terms, right? Just a reminder, 3c squared. This is a term. The terms are all separated by addition and subtraction. So 3c squared is a term. So if I was going to write out all my terms, I'd have 3c squared. I'd have a 4c. I have a 7x. These are all the terms that are listed in this expression. Now careful here. I have a negative 12. Terms are separated by addition and subtraction, but you can always take a subtraction sign and make it plus a negative. So whenever there's a subtraction sign in front of just a term or a number, it really means it's a negative, right? So negative 12 plus, in this case, this here you have a negative 4c squared. So those are like terms. That's a term. Plus 9, that's a term. And then remember, I could take a subtraction, make it plus a negative, add a negative. So it's a negative 6x. So those are all the terms. So this is where we can now combine like terms. What are my like terms? If these are all terms, which of the terms have the same variable and same exponents if they have a variable exponent? So if you look, c squared, here's another c squared. So those right there are like terms. So I'm going to add those up. Where else do I have like terms? Let's see, I'll get another color here. Another set of like terms. This is a 4c. Is there another c? Nope, there isn't. So that's all by himself. But what about the 7x? There is another x term, right, which is a single linear x. It's right there. So those are like terms. I'm going to add those up. And then the last set there is the, remember this is called a constant. The numbers by themselves are constants. So those are like terms. So combining like terms, I add the c's. So 3c squared and negative 4c squared. You add the coefficients, the numbers in front. So it's negative 1c squared. I'll do the x's next. The x's, you have 7x and a negative 6x. 7 and negative 6 is positive 1x. And then I have just this 4c. There's no other c term without an exponent, so I'll have that just sitting there. That's a plus 4c. And then my constants, negative 12 and 9, make negative 3, so I can just say minus 3. So that's one way of writing it. A lot of times we tend to not have to write the ones, so you could actually rewrite this to be negative c squared. And then I'm going to actually put the c. I can rearrange it, the terms, so that way they're in alphabetical order. C, negative c squared plus 4c plus, and instead of the 1x, it's just going to be x, because it's implied. If there's no number, no coefficient in front of a variable, it's just a 1 anyway, minus 3. So that would be number 9. Okay, you follow me? All right, let's take a look at number 10. So number 10, again, I'm going to rewrite this problem because I want to show another way to organize the terms if you wanted to have a method of combining like terms. Almost ran out of room there. Okay, so that's the problem written out again. Something I also tend to do is look at circling while in the line so I can see this is a 2a squared. Look for another term that has a squared. Well, that's a to the third, so that's not like, because it's got to be an a squared. Oh, there's an a squared. Now, be careful. The sign in front matters, so that's a minus. Okay, so which makes that a negative. So I can start with those. I'll combine those. And what do I get? I get 2a squared minus, or a negative 4a squared. That becomes negative 2a squared. So the a squared, the coefficient, the variable and exponent do not change, just the coefficient, because it's the number of that variable term, So I combine those. If I also look, an a cubed. Do I have another a cubed anywhere? No, I think that's the only a cubed. So I can just say plus 3a cubed, because that's the only one. And once I combine them, I go through and cross out so I can kind of see what else I have left. So I have a positive 6a and then a negative 4a. So those will combine. So positive 6a, negative 4a become a positive, so plus 2a. Just the coefficients combine. And then the last is my, so I can cross those out. The last thing is the constants. Positive 12 and positive 2 give me positive 14. So one thing, too, that you're going to see, they tend to rewrite so that way the exponents are decreasing. So really, I should probably put that 3a cubed first, because it's the largest exponent. Then minus 2a squared, because that's the next highest exponent, plus 2a plus 14. So that would be the correct order to write each of those terms in this expression. So this is a full-on algebraic expression with individual terms. All right, guys.